Good morning, students. Today we'll study about maths class 10 chapter 9th, that is application of trigonometry. Okay, so let's begin with, let's see what is the concept behind this. Then after that we'll try to solve the numericals. So now the chapter is applications of trigonometry. Applications of trigonometry. Now, the concept behind this says that we have two things. Number one, angle of elevation. Okay. And another thing is angle of depression. Angle of depression. Okay. Now, we'll draw two things. This chapter also says that only one type of triangle is applicable or used in this application of trigonometry, that is right angle, 90 degree. Okay. So now let us take this is angle theta and this is also angle theta. Now what happens if an observer, here is observer is standing just in front of building and he is angle of sight, and he is he's seeing about on the top of the building that some kind of thing is there. So this angle will be what we'll say the angle with the line of sight and with the distance between this building is called angle of elevation. That is called angle of elevation. Okay. But on this side, for example, if a building is there and on the top floor one observer is there. Okay. One observer is there and he is trying to see in at some distance on the road on which the building is there. So that we will say that is here I'll write line of sight. Okay, line of sight, and the angle which is made here with that distance, the line that is called the this is where I will make. Okay, so the angle with the line of sight and the horizontal line, that is called the horizontal line. Okay, so here the angle will be angle of depression. So you can easily identify when an observer is in the building at the top floor and he is trying to see on the road, okay, on which the building is situated. So the angle with the horizontal and this is called the angle of depression. And here when an observer is on the road and he try to see at the top of the building or tower that something is there, that angle is called angle of elevation. Okay, so that is what the two things are there in this chapter, angle of elevation and angle of depression. Okay, so now we'll try to solve numericals on this. Okay, so let's see what we can do for this is let's read the first numerical behind this, what the numerical says, and we'll try to solve. Okay, now let us see. One question is there. A circus artist is climbing a 20-meter long rope which is tightly stretched, okay, and tied on the top of the vertical pole to the ground. Okay, so now here what is we need to find is the height of the pole. Okay, if the angle made by the rope with the ground level is 30 degree, the rope is making 30 degree. Here what I need to do is we need to find the height of the pole. So let us see how we'll try to solve this numerical solution. Let's see. Now in triangle ABC, in triangle ABC, AB upon BC is equal to tan 30. We know, we have learned the ratios earlier in the previous chapter. So here we'll apply this. So tan means P upon B. So here I will write height upon BC is equal to, wait. No, this is, you can't apply because when given is this. So we'll write this AB upon AC. Okay. Now P upon H. So P upon H is sin 30 degree. Okay. Because here you need to apply this, because what is need to find and what is given is becoming the ratio. So P upon H, that is sin 30 degree. So what we'll do, H upon AC is equal to sin 30. Now what is H upon AC is 20 is equal to what is sin 30? Half. We have done previously. So now H is equal to 20 upon 2, that is 10. So therefore height of the pole is equal to 10 meter. So that is how we try to solve such kind of numerical. Okay. So let us do the second one. Okay. See now the second numerical is given, that is a tree breaks due to storm and the broken part bends so that the top of the tree touches the ground. Okay, touches the ground and makes an angle 30 degree with it. Okay. Now the distance between the foot of the tree to the point where the top touches the ground is 8 meter. Find the height of the tree. Okay. Now according to it, let us first draw a figure. This says, for example, if I consider this one. Okay. If I consider this one, that is a tree breaks due to storm. Okay. And the broken part bends. Okay. So that the top of the tree touches the ground. So what we can say is the top of the part, if I say this one, touches the ground and makes an angle 30 degree with the ground. Okay. So the broken part, it's not completely broken and separate away, but it is still with it. So the broken part touches the ground with and makes an angle of 30 degree. And this distance they have given is only 8 meter. Okay. Now what they are asking is to find the height of the tree. That is total height of the tree. This part plus this. So in this we need to find the two things. Okay. So let us label it. See. How to find it? This is very easy. Let's first take this height. Okay. So let us take now in triangle ABC. AB upon BC is equal to tan 30. Okay. Now tan 30 is given. Okay. So AB upon BC 8 meter is equal to tan 30. And how much is tan 30? 1 upon root 3. So AB is equal to, what we will do? Take this 8 this side. So 8 upon root 3. Now what else? Next step is just to rationalize it. So if I rationalize, what I got is this one. So what will happen? 8 into root 3. Root 3 into root 3. That is 3. So I got the half height, that is AB, I find it 8 root 3 upon 3. Okay. So that is how I found two things. Now we need to find this also, AC also. So how will you find AC? Very simple. Just apply the Pythagoras theorem. So applying Pythagoras theorem, what it says, let's say, according to Pythagoras theorem. Okay. Pythagoras theorem. Okay. Now let us see what we can do. Now we need to find the h, or we will see to find this. I think we can apply two methods. Let us see first one. I am talking about Pythagoras theorem. So what is the Pythagoras theorem says? Hypotenuse square is equal to perpendicular square plus base square. Now we need to find hypotenuse here. Okay. So what is perpendicular? P is, we have just find it, 8 root 3 upon 3 whole square plus base 8 square. So what you got? If I say this, I think it will be more complex in nature now becomes, because here requires more complex calculation. How? See, what is 8 root 3 to 8 root 3? 8 into 8, 64, root 3 to 3 upon 9 plus 64. If I say this, 4, 12, 92 upon 9 plus 64. But I think this method is long, becomes long if I divide it and find it. So what will happen? Let us solve first. 192 plus this. 64 into 9, 6, 47, 576. Okay, this is what? 576. So if you add 192, 768 upon 9. No, now see. If I divide 768 by 9, what I will get? Let us see this number will be divided by 9 or not. 2. If I divide this by 9, what? 52 left with 48, 6, 36. I can apply 5 also. 45, this is 3. Plus, I think this method is solved. Okay. So instead of doing this, let us use another method. Okay. That we have learned about this Pythagoras theorem, because in previous chapter, we learned about that in order to find one side, you need to apply the Pythagoras theorem. Here we can use this also. What we can do is, this is B upon H. Okay, so let us apply H upon B. What is that? H upon B is what? B upon H is the cos. You know the ratio. Now H upon B is the reciprocal of cos, that is sec. So you will use this. Sec third. Now what is H? We need to find. What is B? Is good. 8. Sec 30 is what? Reciprocal of cos 30. So it will be 2 root 3. Okay. So now multiply this 8 into 2 upon root 3. You got 16 root 3. Okay. So what you got here is 16 upon root 3. Okay. So that is what we can do. Or else we can know. Now I got this one. Now this I find. Now see, we need to find the total height of the tree. Okay. So how to find the total height? Total height of the tree, because they are asking the height of the tree. So tree broken part plus this part. So we will add both. So we will easily find the height of the tree. That is now 8 root 3 upon 3 plus 16 root 3 upon 3. What will happen? Just take the LCM. Okay. So 8 root 3 plus 16, 24 root 3. 24 root 3. So now 8. You got 8 root 3. So the total height of the tree is 8 root 3. Okay. So this is the second numerical. Now let us move to third numerical. Now the third numerical is a 1.5 meter tall boy is standing at some distance from a tall building. Okay. Now the angle of elevation from his eyes to the top of the Now building increases from 30 degree to 60 degree as he walks towards the building. Find the distance as he walks towards the building. So what is given is, let us try to solve this question like this, because the question is something like a boy is there, let us draw like this, is 1.5 meter in height, is standing in front of a building, and the building's total height they have given is 30 meter. Okay, but now 30 meters is there, so we'll try to solve this, and what they are asking is we need to find this distance we need to find. Okay, as we walk towards the building, and the angle of elevation is given 30 degree to 60 degree. Okay, as he walks towards the building, the angle of elevation increases from 30 degree to 60 degrees. Okay, now let us see how we can solve this. First take the triangle ABC. So AB upon BC is equal to tan 60 degree. Okay, here AB I will consider 28.5 and BC is equal to tan 60, that is root 3. The total height is 30, but I have to remove the height of the boy, then so I will get the height of the building is 28.5. Okay, so now I got BC, that is 28.5 upon root 3. Okay, now we take the whole triangle here. So in triangle ABD, AB upon BD is equal to tan 30 now. Okay, now what is AB? AB we already know, 28.5 upon what is BD? BD just keep it like this. Now what is tan 30? 1 upon root 3. So finally I got the value of BD. The value of BD is equal to 28.5 root 3. Okay, now what we need to do is we need to find the distance as we walk towards the building, that is CD. So how will you find CD here? Is equal to BD minus BC. Okay, if I subtract this from BD minus BC, I got CD. So what is BD I got? 28.5 root 3 minus what is BC here? 28.5 upon root 3. So what can I do here? Just take an LCM. 28.5 minus, now here if we root 3 to root 3 minus 28.5 upon root 3. Okay, just need to multiply 28.5 into root 3. 3 what is what? 5, 2, 6, 7, 8. Okay, so I got this 85.5. Okay, so I got this 85.5 minus 28.5 upon 3. Okay, so now just if I subtract this, what I will get? So I got this 0.7 and 57 upon root 3. Okay, more we can do with it, just rationalize it. If I rationalize this, just take this value here. So 57 upon root 3 into root 3 upon root 3. So I got 57 root 3 upon 3, 19. Okay, 19 into 3, 57. So now I got my answer 19. Okay, as the boy moves towards the building, the distance we cover is 19 root 3 meter. Okay, such kind of numericals are there. We'll solve now next one. Okay. Fourth question is given, from the point on the ground the angle of elevation of the bottom and the top of a transmission tower fixed at the top of a 20-meter building are 45 degree and 60 degree respectively. Okay, so find the height of the tower. So let us first try to draw its picture representation so that we are able to solve it further. Now, what is given is a building is given that is 20 meter. Now, this is a tower. Let me consider this. Okay, so now this is what they are trying to solve. This kind of figure. Okay, this is a tower. A, B, C. Now what they are saying is from that point of the ground, the angle of elevation at the bottom and top of a tower are fixed at top of a building. So what is bottom angle is given? That is given 45 degree. And what is the top of the tower they are saying? That is it's 60 degree. What we need to do is we need to find the height of the building. That is how we can do it. Let's try to solve it. Now see, what we can do is, let's take this D. So in triangle DBC, DB upon BC is equal to tan 45. So DB is 20, BC we don't know. What is tan 45? 1. So finally I got BC is equal to 20. Okay, now next thing is there. Let's take whole triangle now. In triangle ABC. So what I got? AB upon BC is equal to tan 60 degree. Now AB upon BC is 20 is equal to tan 60 root 3. Now just find the value of BC, that is 20 meter. Now what is AB is equal to 20 root 3. Now what is AB here? AB is h plus 20. Okay, so 20 root 3. So how will you find the height? 20 root 3 minus what I have done is 20. So if I take common 20, I have got is 20 root 3 is my therefore height of the tower. That is I got height of the tower is 20 root 3 minus 1. So this is the fourth numerical we have solved. I am trying to solve different types of numericals, okay, so that we find the different types of figure which can come in the board exam. So now I will solve next question. Okay, let us see. The question is given, that is, two poles of equal heights are standing opposite each other on either side of the road, which is 80 meter wide, from a point between them on the road. Now the angle of elevation of the top of the poles are 60 degree and 30 degree. Okay, find the height of the poles and the distance of the point from the poles. Okay, let us draw, because the numerical says we have two poles of equal height and standing on either side of the road. Now one is making angle 30 degree and another one is making angle that is 60 degree. Okay, now what is need to be done? Let us see. This total distance is given, that is 80 meter. Let us take this x and this is 80 minus x. Okay, so it is given on either side of which is 80 meter wide from a point between them on the road. Now the angle of elevation of the top of the poles are 60 to 30 degree. Find the height of the poles and the distance of the point from the poles. Okay, so we need to find the height. Okay, we need to find height, and one more thing is the distance of the point from the poles. Okay, so let us try it. In triangle ABC, h upon x is equal to tan 30. Okay, so h upon x is equal to 10, 30, that is this one. So x I got h root 3. First root. Okay. Now take this from this in triangle DCE, h upon 80 minus x. But I will take p upon b. Okay, so h upon 80 minus x is equal to tan 60 degree. Now what is tan 60? Root 3. So h upon 80 minus x is equal to root 3. So I got h, where I got h is equal to root 3 80 minus x. Okay. So now what we can do is, here I found h, and there is also, or what else I can do? What else I can do? Okay, from here we can find the height. This is called second, and not this one first. So take this. H is equal to x upon root 3. This one first. So now what we can do? Just equate the heights. So we'll write equating first and second, we get this. Okay. So now equating x upon root 3 is equal to root 3 80 minus x. Okay. Let's find first distance, then we will find the height of the poles. Okay. So now what we can do is just multiply here, root 3 inside. So x upon root 3 is equal to 80 root 3 minus root 3x. Okay. So now what we can do? Take this side there. So let's solve it out. X upon root 3 plus root 3x is equal to 80 root 3. Okay. Now try to solve this in the, let's take LCM now. X plus, so what got here is root 3 into root 3, 3x is equal to 80 root 3. 3x plus x, 4x upon root 3 is equal to 80 root 3. Okay. So now what you got? X is equal to 80 root 3 upon into root 3 upon 4. Okay. 20 root 3 into root 3, 3. 3 into 20, 60. So finally I got x, that is 60 meter, that is this one. So I got BC is equal to 60 meter. Okay. Now, so CD will be 6. What will be CD? 80 minus x. 80 minus 60. I got 20. Okay. So finally, I got the distance from a point to the poles. Now, one more thing is we need to find is the height of the pole. How will you find the height of the pole now? You can put the value of x here. Okay. So h is equal to, what is x? 60 upon root 3. What we can do? Just rationalize it. What we will get? 60 root 3 upon 3, 20. So you got 20 root 3. So the height of the tower is 20 root 3, and the distance from the point to the pole we have found, that is x we have found 60 meter. So BC is 60 meter and CD is 80 minus x, 60, 20 meter. Okay. So this is the fifth numerical today we have solved. That is, we have solved different types of 5 numericals. Okay. So next one we'll solve. Now see, the next numerical we have, from the top of a 7-meter building, the angle of elevation from the top of the cable tower is 60 degree and the angle of depression of its foot is 45 degree. So we need to find the height of the tower. How? Let us first draw its figure. We have given is a building that is 7 meter. in height. Now from its top, you can see the top of the tower, the angle of elevation is 60 degree. Okay. And the angle of depression, see, the angle of depression of its foot is 45 degree. That is what we have got, 45 degree. So we can easily do this, very easy. Now we need to find the height of the tower, h. This is the same 7 meter. Now C, D, E. Okay. Now what we can do is, let's take this one. Okay. So they have not given this one. Let's put this x. Now let DC be x. Now 7 upon x, that is tan 45. Okay. I'm just doing it directly now. Taking P upon B, that is DE upon DC. 7 upon x. We can write also DE upon DC is tan 45. The next step will be, we will put a value of DE, that is 7, DC x, so tan 45. Now we all know what is tan 45? 1. So now I got the value is 7. Okay. Now this is good. Now let us take this one. Now say this is 60 degree and this is x, same, it will be also same. So now in triangle ABE, now h upon x is equal to tan 60 degree. Here I have considered angle of depression. Now I am considering the angle of elevation. So what I got, h upon x, x is 7, is equal to 10. What is tan 60? Root 3. So I got h is equal to 7 root 3. Okay. But the question they have asked is to find the height of the tower. So therefore height of the tower will be how much? AB plus BC is equal to AC, that is height of the tower. So what is AB I have found? AB I have found just 7 root 3 plus 7. Okay. So what is, now consider 7 taking common, we got 2 3 plus 1. So that is the, I am able to find the total height of the tower. So this is the 6th numerical, just very short. Okay. So now we'll move to the next numerical. Okay. Okay. Now next numerical we have, and as observed from the top of a 75-meter lighthouse. Okay. This is the lighthouse. Okay. Its height is 75 meter. Now from the sea level, above the sea level. Okay. Now the angle of depression of the two ships are 30 degree and 45 degree. 30 degree and 45 degree. Now it's angle of depression. Okay. So it's now angle of depression. Now this is 30 degree and this is 45 degree. Okay. See here, consider this. Okay, let's take this dx and let's take this y. Okay. Now we are making an angle of depression. Okay. Let's make it again. Angle of depression. Okay. This is angle of depression. This angle. You can consider this. This one and this one. So this is what small angle, that is 30 degree, and bigger one is 45 degree. Okay. So all this. Now let's find the distance. Okay, between the two ships. Okay. How? Let's consider in triangle ABC. We can consider AB upon BC. That is tan 45. What is AB? 75. And what is BC we have considered? Y. Tan 45 is 1. So finally I got Y, that is 75 meter. Okay. Now let's find this. So now in triangle ABD, AB upon BD, that is I got tan 30 degree. Okay. We all know tan, the ratio of tan P upon B, that is what we are applying here. So now AB is 75 and BD is what? X plus Y is equal to tan 30 is 1 upon root 3. So what we will do? 75 into root 3 is equal to X plus Y. So now what is X? 75 root 3 minus Y. And what is Y here? 75, just we found. So now I got, therefore X is equal to 75 root 3 minus 1. Okay. So finally I found the distance between the two shapes is 75 root 3 minus 1 meter. So today we have tried to solve different kinds of 7 numericals in application of trigonometry, and I hope you are able to connect with me. So if you have any doubts, so you can ask, comment, share, like. So that's all today.